Yeah, area is just length times width, right? So that's what we would do for this first part here. We would just go with the 13.5 times the 14.6, and that'll tell us the area, because they just want area. So nothing crazy on this one. For this one, figures that have the same shape but not necessarily same size, those are called similar figures. And if you ever get this question wrong, you can always go back and always try again. So if you changed it to like congruent or something like that, it'll pop up and say similar question. Always click on that, because then that will give you another chance of answering the question correctly. And you can always get 100, always. Find the scale factor and ratio of perimeters. Okay, so they're giving us the area, okay? Similar trapezoids, and whatever comes first goes in your numerator. So 64 centimeters squared over 9 centimeters squared. So if they're giving us the area, what we have to do is we have to take the square root to get down to the scale factor of ratio of perimeters. So if we want to get to perimeters, you always, if they give you areas, take the square root. Right. And the square root of 64 is something you can just type into the calculator. There's that little button, and then you click 64, and I can show that. Otherwise, if you know it, 8 is what was squared to give you 64. So the square root of 64 is 8. 3 was squared to give you 9. So you should get 8 out of 3. Then we enter it, 8 out of 3. Right. Woohoo. And then the ratio of perimeters is the same thing. 8 over 8 over 3. So perimeters work the same way as the regular scale factors, okay? So if they give you areas, just take the square root to get the scale factor and then the ratio of perimeters. What this is saying is that if I knew a side length, I could figure out the area. So let's say that one side of my similar trapezoids was 4 or something like that. Okay, 4 centimeters, and let's say that was on the smaller of the two trapezoids. Since I know the areas, then I can figure out the side length of the larger of the two trapezoids. Not yet. Yeah, someone just texted me. I thought you were talking about this week's assignment. Totally will. Don't worry about that. So, yeah, just remember when you give the scale factor, you're comparing kind of based on how they give it to you. Okay, they're giving you the big figure and then the small figure. So the scale factor, you're going to compare the big side to the small side, and then you have to reduce. Both of these can be divided by 3. So we're left with 5 over 2. 5 over 2. Yay. Okay, perimeters is the same way. 5 over 2. And then when they want this ratio of the areas, what do you guys think I'm going to do to this 5 over 2? What do you guys think I'm going to do to that 5 over 2? If I want to figure out the ratio of the areas, what do we have to do? What do we do, guys? When we have the scale factor, and the ratio of the perimeters. So we could solve for x, totally could, but if you're given the scale factor, this is how the different figures compare, okay? So one side for every 2 centimeters, the other side is equal to 5 centimeters. So for every scale factor, how would I get to the areas? What do you have to do to the numbers? You have to square it, right? That's all you do. If we have how the perimeters compare, that's what ratio means. It's how the perimeters compare. The perimeter of the big one is 5 for every 2 centimeters of the small one. So if I want to get to the areas, I'm just going to square it. Yeah, you'll be left with 25 to 4. That's all. So if this assignment did not go well for you, please let me encourage you to come back and fix it. So the area of the larger parallelogram is that one. So in this one, guys, this one's kind of interesting. The pair of figures to the right are similar. The area of one figure is given. Find the area of the other figure. So we know the area of the small figure is 20 feet squared, okay? So we know that the way the sides compare is 5 to 30 is equal to, and the area, so I'm going to solve for x here. And when you compare this, you're always going small to big, okay? Small side to big side compared to the small area to the big area. Then we're going to multiply. 30 times 20 gives me 600 divided by 5 is that 120, I think. Yeah, sounds right. We might have to square root that. I don't know. Let's see. Oh, I think I got to square root that. Let's see. I knew it. I knew it. And I'm using my phone calculator. Round to the nearest whole number. Oh, that doesn't make sense. See, then I go to question help and I'm like, view an example. This question help thing is fabulous. Oh, I forgot to square those sides. Yeah. Yep. Okay, that's what I see. It's so easy to forget that. So we have our side length. Guys, the question example. Yeah, I did that. See, it's so easy to forget that. It really is. So we reduce this. Okay, so we get 1 over 6. We simplified it by dividing by 5. And that's just how the sides compare, small to big. Then this is the part that you have to square. 1 squared over 6 squared. 1 over 36. Now we're going to bring in that area. Small to big, small to big. So you first get the ratio of the sides, reduce it, square it, then you set up that proportion. Okay, proportion is 2 ratios that are equal. We're comparing the small to the big. Small to the big. Then we're going to cross multiply. So 36 times 20. That gives us 720 for the area. Boom. Okay. So guys, if you're doing this assignment and it's really confusing, just let me know. I will help you. Set up some time with me. We can blast through this so quick. There's only 8 questions. We can do it together. So let me know. Okay, friends? Does anybody have questions, or if anybody knows, hey, Jen, I'm going to need some time to work with you, let me know. You can even do it right now. So, all right. So today we are going to talk about circles. We already kind of talked about IXL a little bit, and 3D figures. So today you really have 2 assignments due. The other one's just some IXL work time, but there's a circle challenge. And then that 3D shapes one, oh, it's such a nice assignment. It's right in math, in Moodle. It's right in Moodle. So yeah, cool. All right, so this is the first formula you're going to want to write down in your notebook. We're going to talk about circumference. What does circumference mean? What is the circumference of a circle? What does that refer to? Can you guys tell me? What's the circumference? Oh, okay, 1 second. Yeah, that's the area around a circle. And we wouldn't say area, we would say the distance around a circle. Okay, so circumference is distance around. Hold on 1 second. I have someone who listened and took me up on my offer. Woohoo! So I'm just checking my calendar. Da, 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 da. All right, let's see. So, circumference, distance around a circle. So here's my circle. And when we are referring to that circumference, that's the distance around the circle. What's a diameter? What's a diameter? Because circumference involves diameter, that's this D. Maybe not half the radius. You're real close there. Okay. So the radius is from the center of the circle to the side. Yeah. You have the right idea. We would just say double the radius. Yeah. Very good. So radius is half your circle, and it's got to go through the center. And diameter is the whole length of the circle. Good. So give the exact, so we want to find the circumference of a circle with a diameter of 10. So since we're given a diameter of 10, we're going to use this circumference equals diameter times pi. And remember pi is that magical number that refers to a circle's circumference by the diameter. It's one of the questions in the homework. But every time you divide the circumference by the diameter or something, I think it's diameter, you should get pi. You should. Yeah. And that makes sense, right? Because if I solved this for pi, according to this formula, pi is equal to the circumference divided by the diameter. So, and that is true. That is what you will get every single time. But we just want to find the distance around this circle. So, and they're going to want an exact answer and an estimated answer. So first, the exact answer, we're going to take diameter of 10 times pi. And guess what? 10 times pi is just 10 pi. I'm done. That is my exact answer. Cool. What would I do for my estimated answer? What do you guys think? What would I do? Yeah, I would take 10 times pi. And you'll see some of your assignments tell you to use 3.14. I would prefer if you use the pi key, and I will show you about that. I'm just scheduling my friend that wants to meet with me on Friday. Cool. Okay. Done and done. So according to this, and according to you guys and your smarts there, I'm going to take 10 and multiply by pi. I'm definitely going to use Desmos because it's just awesome. So I'm going to take 10 and multiply by the pi key on there. And we want to round it to 2 decimal places. So that means 2 places after the decimal. So I want that 1 to be the last place, and that 5 bumps it up to a 2. Ooh, my son's gonna get in trouble. He's being sassy to his daddy. Oh, man, that kid, I tell ya. I tell ya. Ooh, look at this. Someone's got this one on there. A circle with a radius of 8. So that one has a radius. So what formula are we going to use for that one? Since we are given a radius. What do you guys think? Since I'm given a radius, yeah, pi times radius squared. If I'm given the radius, I'm going to use the radius formula up top. You're so right. So I'm going to go circumference equals 2 times 8 times pi. 2 radius pi. Good. So we are left with 16 pi. And then what would I get if I did the exact answer? I'll put the link for Desmos. Cool. Mariam said, oh, I sent it to one of you privately. Okay, cool. So I have the link for Desmos in there, but unfortunately you can't click on it anymore, which is really annoying. But Mariam says it's 50.24. Let's see. Pretty sure that's right. Oh, Mariam, you might have used the pi key, or the 3.14, but using the pi key, you should get 50.27. But pi key might have this one. And it'll tell you on Desmos, if not on Desmos, on Math Excel if they want you to use 3.14. All right, so what are we given for number 3 there? Are we given a diameter or a radius for number 3? We are given a diameter because it goes all the way across this circle. So we're going to go diameter times pi. So my exact answer would be what for the circumference? What would my exact answer be? And you can write it on the screen or type it in chat. What do you guys think? What would my exact answer be if I'm following the circumference equals diameter times pi? Yeah, it would be 18 pi. Very good. 18 times pi is just 18 pi. And that is the exact answer. And that might be confusing because sometimes people think the exact answer has the decimals, but no, that's actually the rounded or the estimated answer. So now go ahead and multiply that 18 times pi and tell me what you get for the rounded answer. Yeah, Mariam says 56.55. Do you guys agree? What do you think? Guys agree there? 56.55? Yeah, that's what I got too. Very good. And in this case, because there's an actual measurement, we would say centimeters. Remember, circumference does not have squared after it. That's only area. And speaking of area, let's do some area. Cool. So for area of a circle, there's only one formula, which is cool. Makes life a lot more simple, I suppose. So the area of a circle is pi times the radius squared. That is different than multiplying by 2. Okay, remember, you have to multiply by itself. So another way of looking at area is pi times radius times radius. It's another way of looking at it. So, okay, this one, we have a circle with a radius of 10 centimeters. So here's my formula, pi times radius squared. What's my exact answer for that one? Yep, very good. Yeah, 100 pi is my exact answer because I'm going pi times 10 squared. Oh boy, my kiddo. Okay, so what would the rounded or estimated answer be then? What would my estimated answer be if my exact answer is 100 pi? What do you guys think? Yeah, very good. I would go for my exact answer, and just to show it again, just to make sure we're on the same page, I would go I would go 100 times pi. 314.16. 314. You guys can't hear yelling, can you? You guys, you don't hear anything? Good. Good, good, good. My son's just having a difficult moment, so he can be kind of verbal about that. So, yeah, my apologies there. Okay. So, okay, let's talk about number 2. We want to find the area of this circle. Area equals pi times radius squared. Area equals. So, okay, what am I going to put into the formula here? What would I put in that formula? What am I given there? Am I given my radius? Am I given a radius or a diameter in number 2? I'm given a diameter, yeah. So what am I going to put in the formula? Not going to put 18 in there because that's a diameter, and I don't want diameter. I'm going to put 9 in there because 9 is my radius. Very good. So it's pi times 9 squared. What is 9 squared? 9 times itself. What would that be? 81. Yeah. So my area is 81 pi. That's my exact answer. What would my estimate be? Oh, did someone write it? Someone wrote it. My bad. That is totally correct. Very good. So what would my estimate be? If 81 pi is my exact answer, what is my estimate? What is 81 pi? What is it? What do you guys think? We got a lot of people in here who can answer, and it makes it yeah, it makes it go a lot quicker. So Corey, Mariam, Isabel, does anybody have questions on how we're finding it? Sarah, you rock. Very good. Melissa, Taylor, Aiden, Declan, Kira, Lily. We just want to enter it in. Yeah, we all want to be calculating because it makes it go a lot quicker. Good, good. Let's just make sure we're all calculating here. So as Mariam and Sarah have accurately and 100%ly said, we get 254.47, which rounds to 0.5. So it just depends on what space they want to round to. Yeah, and that's really good, guys. I'm glad. It's easier for me to tell if you answer questions and stuff to the best of your ability. Oh, it's so distracting with that kid yelling and screaming. Oh, don't forget, if you have a label there, we label it as centimeters squared. So, yeah. Area is always squared. Okay, so that's kind of like the last week's stuff. Yeah, that's okay. Totally fine. It depends on what Math Excel wants. So, you rounded correctly. That's what counts. So for your homework, you're going to have questions like this. It's going to be circle questions that are were word problems. Okay, so Kira, I love that you admitted it. That's so amazing, and we can obviously work on that together. But if you have any questions that come up, that would be really cool if you ask it, because other people might have the same question. Okay? So we'll do some more examples. A pizzeria will bake and deliver a round pizza with an 8-inch diameter. First thing, I am a huge advocate for drawing stuff out. So this is a round pizza with an 8-inch diameter. Find the exact area on top of the pizza and use an approximation. Use 3.14 as an approximation. So they're telling you it's okay to round here. And they're telling you don't use the pi key, just use 3.14. Okay? So our formula for area, we're going to write that down first. Area equals pi times radius squared. So area equals pi. Okay, and here's my question. If my diameter is 4 on the pizza, that's the distance across the whole pizza, what is my radius of the pizza? 4. Yeah, so 4 is what's going to go into my formula. So 4 squared. What is 4 squared? Did I say the answer? Oh my gosh. I apologize. My bad. I'm a little distracted. My anxiety is a little high right now. My child is in the next room screaming his head off. So, yeah, can't help it. It stresses me out. I tell you. So, okay. So 16 is 4 squared. Again, this is the same as pi times 4 times 4. So very cool. So definitely 16 times pi. And now the problem is telling me to use 3.14 for pi. So instead, oh, thank you. That's okay. It happens. So instead of pi, I'm going to change it to 3.14. Okay, what is 3.14 times 16? 50.24. Did you guys get that? And it's area, so we're going to say square inches. Cool. So that is the area of my pizza. That's a good amount of pizza. All right. Num num. Actually, 8 inches across. That doesn't seem like a very big pizza. I don't know. Have you guys ever had the giant 20-inch across diameter? Oh, so good. So delicious. Okay. Questions on the pizza challenge there? Okay. So if part of your homework is going to be to find the area of the shaded sector of the circle. Okay. Sector area. Yeah. Now there are formulas for this. There totally are. And this is actually a trigonometry concept. So, you know, because it definitely depends. What's tricky is you'd think that we could just find the area of this circle, right? And divide it by something. That might work for this one. We'll have to see if that works. So what's my area of a circle formula again? What is that? What's that formula again? You can just, you know, write it out. Yeah, pi r squared. Yeah, very good, very good. So I would take pi times my radius squared. So for this formula, we can start it off. We can go pi times my radius, which is, what's my radius here? 16. Yeah, pi times 16 squared. And pi times 16 squared, what does that give us? Let's see. I got glasses to help block the blue light because it's been giving me headaches from the computer, and now my face recognition on my phone does not work. No. So that's 256 pi or 804.25. Okay. Cool. Very good. Okay. Yeah, that's very good. Very, very good. So now what do you guys think I should be able to divide by to get the area of this sector? Since it's a nice 90-degree angle, right? That's what that little chunk means that was taken out of my area. What should I be able to divide by to get the area? Oh, I wrote it on there. Oh my gosh, guys, oh, sorry. It would be dumb to erase it now. Okay, so by 4, you'd think that we could take that area and divide it by 4. And if we did that, that would tell us each section, right? You guys agree with my thinking? 201? Yeah, so then 201, that's the area of one of those little sections. What would I multiply that by to get all 3 areas? By 3, yeah. So is that 360? What? No way. No way. It could be. Could be. 201 times 3. Oh, 603. 603-ish. Just kind of switching numbers on you. Now let's see if that works. Okay, there is a formula for area of a sector. There is a formula, and it involves that that 90-degree angle. Area of a sector of a circle. Okay, so the actual formula has us take the angle that we're given. Oh, guys, I think we did it right. I think we did, according to the formula. Yeah. So the actual formula has us area of a sector. Has us take the area of a circle and multiply by the angle that we're given. And we'll call it angle, because I don't want to confuse you guys. Out of how many degrees is this? Oh, Mariam's got it. Very good. Area of a circle. It's not really the area, but the amount of degrees in a circle. What is it called when you kind of spin all the way around? How many degrees is that? Mariam kind of has it, but I'm going to ask it again. Yeah, 360. So you'll take the area of your circle and you'll multiply it by whatever angle they give you out of 360. So we would take pi times 16 squared, and our angle that they gave us is 90 out of 360. And if I were you, I would go straight to Desmos. Like how I said that, Desmos. So we would take pi times 16 squared times, and then we'll put it in parentheses, because parentheses keeps things together, neat and tidy, if you will. Okay, see, I feel like that is, oh, that's the little section. Yeah, because guys, if I put in 90, then I actually found the area of this section. So you do get 201, and then you have to multiply by the three sections. Cool. So if this is 90 degrees, then this is 270 degrees. So you use whatever angle you're given. So let's do another one. Let's do another one there, guys. Okay. A sector of a circle is shown. Okay, this one is a little bit different for the area. I'm going to change it slightly. We're going to say this area is, I don't know, let's say 25 degrees. Okay. So same deal. I'm going to take pi times radius squared. We're going to ignore this for now. And we're going to multiply by the area, the angle that we're given out of 360. Okay. So what is my radius in this area of a sector? What is my radius in this section of a circle? What is the length of my sector? Is it the 4 or the 25? Yeah, it's going to be the 4. And then the angle that I'm given is 25 out of 360. And then we're just going to enter that into Desmos. And what's awesome is I already kind of typed it in, so I just got to go back and change the values there. Cool. So we are left with 3.49 as my area, which makes sense because it's a small little section. So 3.49. What? No, I didn't want to go to that. Stop that. Okay. My slides. No. Okay. Cool. All right, now here's the thing about this area of a sector. 3 point, what did I say? 4 centimeters squared. Cool. Does anybody have questions on that first? Did I lose anybody? I know we're switching formulas quite a bit. Okay, cool. So it's just taking your area and multiplying by the angle out of 360. Now, sometimes with areas of a sector, sometimes instead of being given a central angle like that, you're given an arc length. So area of a sector given arc length. And that's just another formula. Yeah, it's just a different formula. I'm just looking up the formula so I can give it to you guys accurately. I gotta be honest, I'm not really sure why we're doing this, but that's okay. It's a good little, I think it's good. And it's just another formula, that's all. Arc length and area of a sector. Yeah. Oh, we're almost done, you guys. You know, I'm gonna have to look at this one because I don't. Area of a sector. I think we just need the. Oh, we have to divide it. Yeah. We have to divide to get the angle measure. So sometimes what you're done is you're given. Okay, you think so? Yeah, it could be. That sounds good. Yeah, you got to get the angle measurement. Yeah, very good. So sometimes you're given an arc length. And the way that arc length, that's the length of the arc, you're given a portion of the circumference of a circle. And if you're given the arc length, what we want to do to get back to the actual angle is we want to take that arc length and we want to divide by the number of radians, by the radius, the radius. So if we divide that, that will give you the degrees in the angle. I'm going to double check if you guys need to do that in your homework because that seems a little beyond what we want you to do there. So I will check on that one for you. And if you do, then I'll send out a quick video. So yeah, you'll also have to deal with some vocab with 3D figures today, okay? So just make sure that you have vertex, edge, face, base, you know, just look on Moodle and go through it. Okay, Google is your friend if you can't remember any of the shapes, but it's all on Moodle there, so make sure you guys are checking that. And you do have a question about 3D shapes in real life, and I just want to remind you, use Google. It's really fun to look. So, yeah. But that's all I have for you lovely people today. I will double check on that question and I will. Okay. Yeah, Mariam, I think you're 110% correct there. I'm just going to double check that you guys need to worry about that cuz I don't want to do it if you don't have to. So, yeah. But that's all I have for you guys today. Let me know